Okay, a couple more problems from section 0.3 involving simplifying expressions with exponents. Start over here with number 22. Okay, they give us an expression, z to the power negative 3 times 3 times z to the power 4. Okay, and the directions say simplify. Okay, simplify this expression containing exponents. Okay, well, there's not much we can do. We're multiplying three things together. There are parentheses here, but we don't need them. We're not doing anything to this 3z to the fourth other than multiplying it by z to the power negative 3. Okay, so if you want, you can actually even erase those parentheses. Now, if I was squaring this or something, we'd have to deal with that. Okay, so maybe I'll start with doing that. Okay, so what are we doing? We're actually multiplying three expressions. Now, two of them are powers of z. We can combine those. So I'm going to leave the 3 out front. And I actually want to multiply these together and combine them to 1 power of z. Okay. You actually don't have to worry about the powers being positive or negative because there's a simple rule for this. When you multiply two powers of the same expression together, you add the powers. Okay, so I've got z to the power negative 3 times z to the power 4. That's going to be z to the power negative 3 plus 4. Okay, so this is really just 3 times z to the power positive 1, which we can just write as 3z. Okay, so not bad. And then obviously here there's nothing else we can do because we don't know what 3 or what z is. 3 times z is just as simple as it can get. Okay, so let's go over to this one. This is number 35. They give us an expression with radicals and they say simplify by removing all possible factors from the radical. Okay, well, this is the cube root of 144 times x to the 9th times y to the power negative 4 times z to the 5th. Okay, a lot of ways you can go about simplifying this, and again, I could say one is better than the other depending on what the answer turns out to be, but basically we can take things out, we can take factors out of the radical if they appear 3 times, because this is a cube root. Okay, so what you really want to do is find any factor of this expression that is a factor 3 times. Okay, so basically that means start by factoring. Okay, so we've got 144. Well, how does 144 factor? Okay, well, 144 is 12 times 12. Okay, so you could start there, but actually you want to factor it completely. Okay, 12 and 12 factor further. This 12 is 2 times 2 times 3, and this 12 is 2 times 2 times 3. Okay, so altogether, the completely factored version of 144 is 2 times 2 times 3 times 2 times 2 times 3. Okay, so I factored 144 into as many small pieces as I can. Okay, now here's the idea. Any factor that appears 3 times, we can take out of the radical because this is a cube root. If it was a square root, we'd be looking for factors that appear twice. Okay, so I'm going to kind of keep that in mind as I move on to the next one. Okay, how about x to the 9th? Okay, well, if that's 9 x's multiplied together. So any 3 x's multiplied together, I can bring out as a single x. Okay, so x to the 9th is x cubed times x cubed times x cubed. Okay, that's my 9 x's. Okay, I'm just grouping them in groups of 3 because each group of 3 can come out as a single x. Okay, now y to the negative 4, a little tough, but maybe we could do this one in 2 steps. Y to the power negative 4 is 1 over y to the 4th. So actually that's 1 over y. Let's do it this way. 1 over y cubed times 1 over y. Okay, I multiply this together, it'll give me 1 over y to the 4th, which is exactly what I have here. Okay. And there's a little bit more in here, I can barely fit it all in here. In fact, let me go ahead and rewrite what I have, just clustering it together a little bit more. Okay, so I had the 144, which is 2 times 2 times 3 times 2 times 2 times 3. I've got x cubed, x cubed, x cubed, 1 over y cubed, 1 over y, okay, and z to the 5th. Well, that's z cubed times z squared. Okay, now it's, again, a pretty big problem here. I could almost have done this one on the board by itself. But any factor that appears 3 times is something I can remove, okay, by taking the cube root. Okay, so let's start with the numbers, the whole numbers I have here. Okay, I don't have 3 3s, but I do have 3 2s. Okay, there's 3 2s. So I can take the cube root of 2 times 2 times 2, which is a single 2, and bring that outside. So once I do that, I've effectively removed 3 of those 2s. Okay, So this 2, I can't do anything with. It doesn't factor out any because I need 2 more 2's to get a cube root. Okay, same goes with 3's. I only have 2 3's. I would need 3 3's to take the cube root of that. Okay, well, what else can I take the cube root of? There's 3 x's multiplied together. So if I take the cube root of those 3 x's, that'll bring an x outside of the radical. Okay, but I also get an x from this one and an x from this one. Each 3 x's I multiply together, I can get 1 x out of the cube root. Okay. Okay, so some things are coming out, some things aren't. Okay, 1 over y cubed. Well, that's 1 over y 3 times, right? So I can bring that one out. Okay. This 1 over y, can't do anything with. Okay. And then when I get to the z's, I've got z cubed, which is 3z's again. I can take out one of those, cancel these, and z squared, which isn't going anywhere. Okay, so let's collect everything that we've got here. The big one here. Okay, so these are the things that came out. What's left is 3 times 2 times 3. Well, since they don't come out, I can go ahead and multiply them back together. 3 times 2 times 3 is 18. And then if you look carefully, all of my x's came out. I still got a z squared over y, so I can write z squared over y like that. Okay. And then basically I'm done. The only thing I need to do is combine these x's, because typically we don't write x times x times x. We write it as a power. So that's 2x cubed, okay, times z, okay, times 1 over y, which will just put a y in the denominator. Okay. And that's times the cube root of 18z squared over y. Okay, and that's it. Now the only thing that I could really suggest here that somebody might do differently is, instead of writing the 1 over y, just leave that as y to the power negative 1. So in the book on this one, if you looked in the back, there's a chance you could see 2x cubed times y to the power negative 1 times z. Okay? But typically the book doesn't like to leave an answer with negative powers, so they would probably write it this way. Okay, so that's it.